welcome to SonarQube tutorial. So today we'll be discussing about SonarQube and its various terms and technologies used in the tool. So this is our first lecture. Let's get started. So SonarQube is not just a SAST tool. SAST means Static Application Security Testing. So it's not just used for security testing, but moreover it is used as a code quality tool. Now, SonarQube is developed by SonarSource, which is available as open source tool. Also, it has various enterprise versions which can be used for continuous inspection of the code quality. It also detects security vulnerabilities, code smells, security, and supports 25 plus programming languages. Uh, it provides various reports on the source code, like how many comments are there, bugs are there, code coverage is there, are we following this coding standards, how many duplications are there in the code. And also displays a dashboard, nice kind of dashboard where we'll have all this information gathered together along with the test and the coverage. So these are the few languages which I have mentioned in the slide at the bottom. So this we will be using to SonarQube to analyze all these languages like Java, JavaScript, Python, XML, HTML, etc. So once you install the SonarQube, your dashboard will look something like this. So here you can find all the things I was discussing, like uh, bugs, vulnerabilities, code smells, coverage, etc., etc. So let's go and understand all the technical terms used in SonarQube. Now, first comes the quality gate. So quality gate is of two types. It can be default, it can be custom. So by default, if you don't configure any set of rules, it takes the default one. Whether also you can have your own custom rules defined for the quality gate. We'll come to that later, and we will see in the project once we create our own SonarQube dashboard and onboard the projects. Then we'll come to that. Now let's go get into the definition of quality gate. Now quality gate is a collection of various metrics of the projects which define where we define the threshold limits. So those limits or the rules define the pass and fail criteria of the project. Now again there can be like custom quality gates or the pre-built ones. So the pre-built which Sonar provides is the default quality gate. Now the quality gate has set of rules, like we can set quality gate on like whenever the code coverage is greater than 80%, then only our build or the project should pass. So we can set such kind of quality gate which will be having rules like coverage, and then how many security bugs are there. If it is a less than 3 bugs, then we can pass the build. So those things we'll be checking later. This is just for you to understand what a quality gate is. Now coming to the reliability or the bug section. So if you go to the dashboard above, you can see here quality gate is here, yeah, the reliability is also here, you can see. So reliability contains the bugs. Now SonarQube identifies a set of rules which represent something is wrong with the code. Well, there can be something wrong, or else it might be a false positive. It can only be understood once you onboard the project and your project is stable enough, and the dev team can help you to find it whether it is really a bug or it's a false positive. So those things can be defined at a later stage. Now coming to the security or vulnerability section. So here it displays the security bugs or the vulnerabilities detected in the source code without compiling the code here. So here we can find like what are the number of vulnerabilities in the source code of the project. Based on that, we have like several ratings: A, B, C, D, E. So if you see here, we have A, B, C, D, E rating. So A is when you don't have any vulnerability, that is vulnerability is 0. So B is like at least you should have one minor vulnerability. So then it will be listed as B. So accordingly, the category is defined. Again, we'll come to it when we configure the project, and we can discuss more on it. What there are various further classification of the security part, like security hotspot and vulnerability, which will not be discussing here now. Coming to the maintainability or code smells. So this is found here. If you can see maintainability or code smell. Code smell is just a bad smell or order in the source code. The SonarQube introduced code smell with the version from 5.5. Now, in computer language, it refers to the symptoms which may indicate that there may be a deeper problem with the source code instead of the surface problems. Though these are not technically incorrect, but it may disrupt your current. It may not disrupt your current functioning, but it indicates the future problems or maybe some design issues or architecture weakness, which may slow down the development process. So dev team or any other team can in fact have some efforts efforts listed in the sprint to solve these code smells. Maybe if you suppose you have around 10 code smells in the source code, so you can have your own sprint and decide how many code smells you want to resolve per sprint. So code smell, you can see a funny image here, like here the code stinks. uh, and similarly, the code quality, like when we have passed all the quality rules, then only the gate is open and the build or the project is allowed further. Now comes the coverage part. Now coverage part here it's like we are covering the unit or integration tests. So we can get the coverage of the test cases. Now comes the duplications. So duplication is like how many lines or how many blocks of codes are duplicated again and again in the source code, how many functions are duplicated. So those things should be reduced to minimum. Size. Now comes the size part. Here we can see the source code, how many lines are there in the source code, how many classes are there, comments, or how many files are there. So basically you can see the size here. Once you enter here, once we configure the project, we can see from here. Once we click the Java, and then we can see that. Now comes the complexity. Complexity is like how difficult it is to understand your code. Like whenever a newcomer or a new candidate joins your team, so how difficult it will be for him to understand the code. So if you see the image here, like if the code is written in a very complex fashion, so he may be confused initially about the source code and how to work on it. Next is I think I missed the languages part. So language part is like it tells us what programming language are we analyzing for the project. So if you come up in the dashboard here, we can see like the various projects are there. Like this is Java based. Then we have XML, Java. We have JavaScript, HTML, Python, etc. Now so yeah, so this is the image for the security vulnerability, which indicates like uh, the it's not much secure with the broken lock image. Now these are few projects which will be configuring in our SonarQube once we install it and make our SonarQube server up and running. So we'll be focusing and onboarding our Ant, Maven, Gradle, Node.js and Python based projects.